I'm Andreas Hamberger, and this is the Hamberger Report, where I cover AI governance, enterprise architecture, and the technology decisions that actually matter to the people who have to make them. If you find this useful, subscribe and hit the like button. It helps more professionals find the channel. Now let's get into it. In February 2026, SpaceX filed with the FCC to launch 1 million satellites, designed not for communications, but as orbital data centers. I'm Andreas Hamberger. This is the Hamberger Report, where I cover the orbital economy and what it means for AI governance on Earth. The pitch behind this filing is simple. Terrestrial AI infrastructure is running out of power. XAI is reportedly losing $1 billion monthly, sustaining its Colossus supercomputer in Memphis. Moving compute to orbit frames that burn rate as future infrastructure and supports a SpaceX valuation. Analysts are estimating at $1 trillion ahead of a potential mid-26 IPO. The problem is the physics. Independent engineering audits suggest the projections in the filing are optimistic by 50 to 100 times. In orbit, heat cannot be shed through convective cooling. Radiative cooling, the only mechanism available in vacuum, is far less efficient. The mass required to deliver the claimed 100 gigawatt capacity is approximately 1 million tons of satellite. Current launch capacity, even with Starship fully operational, cannot approach that figure. Radiation-hardened processors, the only chips that survive LEO reliably, lag several generations behind terrestrial equivalents in clock speed and power efficiency. So why file? Because the narrative itself has value. This proposal establishes a strategic marker for decoupling AI growth from a failing terrestrial power grid. Competitors must now respond to it, regardless of whether the engineering holds today. While SpaceX files for a 1 million satellite constellation, the orbital environment it wants to operate inside is already at breaking point. Researchers have been tracking what is called a crash clock. CRASH stands for collision realization and significant harm. It measures the estimated time to a cascading collision event if all satellite avoidance maneuvers were to cease simultaneously. In 2018, that figure was 164 days. By late January 2026, it had dropped to 3.8 days. That is not a trend line to monitor. That is a margin that has collapsed. Within the Starlink constellation alone, close approaches defined as 2 objects passing within 1 kilometer now occur approximately every 11 minutes. Each satellite executes an average of 41 evasive maneuvers per year. At this orbital density, AI is managing traffic safety in real time. Human supervised control is not operationally possible. On the 2nd of February 2026, SpaceX unveiled Stargaze, distributing 30,000 star trackers across the Starlink constellation to provide continuous tracking of nearby objects. Ground-based radar cannot match this. In a validated test, Stargaze detected a third-party satellite maneuvering to within 60 meters of a Starlink satellite, published an updated trajectory, and the collision risk was reduced to 0 within 1 hour. SpaceX is making Stargaze data freely available to all operators. That is the right call. It also places a private corporation at the center of global space traffic management infrastructure, with no binding governance framework over that role. New Zealand is not a bystander in this. MethaneSAT was a $90 million flagship mission for the New Zealand space sector and the Environmental Defence Fund. It launched in March 2024 with a 5-year operational plan. On the 20th of June 2025, after 15 months, the satellite lost communication. Optical imagery confirmed it was intact, but tumbling in what investigators called an off-nominal orientation. 3 candidate failure points were identified: a circuit board failure in the bus avionics, a component failure on a spacecraft bus interface, or a thruster-induced power surge that cascaded across subsystems. The root cause could not be isolated. Despite the loss, the mission produced meaningful data, 97 measurements over global targets, including 13 over Aotearoa. delivering datasets that are already informing methane emissions policy for pastoral farming. That is a real return from a pastoral mission. The government's response came on the 13th of February 2026. New Zealand's national launch limit was increased from 100 to 1,000. New Zealand currently ranks third globally in launch capacity behind the United States and China. The target is to double the space industry's value to $4 billion by 2030. Atmospheric scientists have raised concerns. High-frequency launches could deposit soot and alumina into the stratosphere, and New Zealand's geography may create particular exposure to localized ozone depletion. Those concerns are on the public record. They have not been resolved. A Trans-Tasman memorandum with Australia, signed in early 2026, adds the framing that space technology is now fundamental to modern military operations. That designation has governance implications well beyond launch schedules. Let me bring this to the question that matters for CIOs and enterprise architects. At Black Hat 2025, researchers demonstrated how unauthenticated uplinks to satellite on-orbit control software could allow malformed packets to reach attitude control code, giving an attacker the ability to shut down or deorbit a satellite remotely. In parallel, an AI system identified a flaw in NASA's CryptoLib security software that 3 years of human code review had missed. The AI found the vulnerability and proposed a fix in 4 days. The consensus response is a zero-trust mandate for orbital operations. The security perimeter shifts from the ground station to the individual satellite workload. Every packet is authenticated. There is no implicit trust, regardless of source or prior session. Hybrid cryptographic architectures, combining classical algorithms with NIST-approved post-quantum cryptography, address the harvest now, decrypt later threat that emerging quantum computing capability will eventually make real. The governance gap is agentic AI. Every surveyed space organization has agentic AI on its 2026 roadmap. Over 60% cannot yet terminate a misbehaving agent or enforce what researchers call purpose limitations. The emerging answer is bounded autonomy, defined operational limits, mandatory escalation paths to human operators for high-stakes decisions. It is an interim control, not a settled framework. The pattern should be familiar. AI capability is moving faster than the governance structures designed to manage it. The difference in orbit is propagation. A governance failure does not stay contained to one organization. It cascades across every satellite in the neighborhood. If you are tracking what the commercial space race means for your organization's AI governance, subscribe to the Hamberger Report for daily insights. That is the Hamberger Report for today. If this was useful, subscribe and hit the like button. It helps more professionals find the channel. You will find links to everything we covered in the description below. I am Andreas Hamberger, and I will see you tomorrow.